What is experimental probability? Think about this question during the lesson. If you roll a number cube and land on a 6, you win a prize at the local Hispanic festival. Cecilia tracks the number of players who roll a 6 on Saturday and Sunday. What percentage of players won a prize? The first step is to determine the relative frequency of winners on Saturday and Sunday. In a probability experiment, you carry out or observe an action repeatedly. Each observation of the action is a trial. The relative frequency is the ratio of the number of times an event occurs to the total number of trials. In this case, it is equal to the ratio of the winners to the total number of players. We can find the relative frequency for Saturday and Sunday and for the total number of players. The relative frequency on Saturday is about 17 6/10%. The relative frequency for Sunday is about 20 3/10%. So the relative frequency for the entire weekend will be between 17 6/10% and 20 3/10%. For the total number of players, the relative frequency is 50 divided by 263, or about 19%. The relative frequency of an event can also be called experimental probability. Which formula can be used to find experimental probability?
Select your answer.
The experimental probability of an event is equal to the number of times an event occurs divided by the total number of trials. The experimental probability of rolling a 6 on the number cube is equal to 50 divided by 263, which is about 19%. Based on the data, there were actually 50 winners out of 263 players, or about 19% of the players rolled a 6. You can compare the relative frequency for each day to the overall totals. Now you know about experimental probability.
During the following weekend of the Hispanic Festival, Cecilia recorded 47 winners out of a total of 275 players. What is the experimental probability?
So we're going to use the formula they gave us, right? P event experimental probability, right? The probability of the event occurring. So there were 47 winners, and that was out of the total of 275 players. So to find that experimental probability, you have to divide by the number of times it happened to the total number of possible times. So the 47 is divided by 275, and that is approximately 17%.
Joaquin also kept track of players and winners for his game during the Hispanic Festival. Based on the results shown in the table, how many winners should he expect if 300 people play his game?
We have the table here that tells what was happening on Saturday, Sunday, and then the total. It also tells us to drag the tiles to build a proportion. So one proportion we can have is the total number of players on Saturday. And the number of winners on Saturday. So that would be one of our proportions. And also we can have for Sunday well, they don't have the Sunday numbers, but they do have the total number of people that played on that weekend, which is 416, and then take the 71 total winners from that weekend, and that's another proportion that we could have. So the proportion they use to solve the problem is the total number of winners over the total number of players for that weekend. And so the winners is what we're trying to find. So if 300 people play this game, here's that 300, we need to solve for W. So we want to get W, which is our winners, variable by itself. So we have to do the inverse of division, which is multiplication. So we would be multiplying 300 on both sides of the equation. And so the 300s cancel out on this side of the equation, and you're left with the W. And then on this side, we are multiplying the 300 times the 71 divided by 416, and that is approximately 51 2/10. So that means there are about 51 winners he could expect out of the 300 possible players. We're going to use the same formula that was used in the example. Proportion was used was 71, which is our total number of winners, over 416, the total number of people playing. And they asked for what if 450 people played, how many winners would that be? So we're going to do, again, the same steps. We're going to solve for W. So we're going to do the inverse of division here and multiply by 450 to both sides of the equation. So we're going to cancel out the 450s on this side, and then we have approximately how many winners. So we do 450 times 71 divided by 416. So that would give us 76.8, and I'm going to round that to 77 winners. So there would be approximately 77 winners if 400 people played.
In a carnival game, the winner is randomly given one of 4 prizes. How can you simulate a winner being given a prize?
Step 1, design a simulation using a spinner. So that's a model of a real-world situation that can be used to find probability. So this spinner has 4 equal sections. Each equal section represents one of the 4 prizes. Then we have step 2, run the simulation by spinning the spinner. So you have your number of trials, 10, that means how many times you actually spun the spinner. Number of A results. So anytime you get an A, that's how many times in that number of trials. Experimental probability of winner receiving an A is using that proportion to create that experimental probability of a person choosing the letter A. And so now, step 3, after more trials, the experimental probability of a winner receiving a certain prize gets closer to the theoretical probability of 25%. So the simulation accurately models the situation. So 25% came from the fact that these are 4 equal parts, and so theoretically people should choose any one of these letters 25% of the time because it's an equal portion of the spinner. Just wanted to point that part out.
In a game, each of the 13 players has an equal chance of winning. Describe how you could use a standard deck of cards to simulate an outcome of the game.
One way you can describe how you could use the cards would be if you take the cards. A deck of cards has face cards, so that's ace, king, queens, and jacks, and then you have your number cards. You could assign each of the 13 players one of the cards. So one player, if they pull out an ace, they win. If a player pulls out a 10, anytime they pull out a 10 or someone pulls out a 10, they win. If someone has threes, everyone who pulls out a 3, that person assigned the 3 wins that game. So that's one way you could simulate an outcome of a game with a deck of cards, which is 13 different cards. So that could be easily used for that.